Jain friends, myself Sachin Jain, Assistant Professor, Department of Computer Science and Engineering, Ajay Kumar Garg Engineering College. In today's lecture, we will discuss the topic first and follow and LL1 parser. So these are the table of content outline of this lecture. Firstly, we will discuss what is parsing. Second one, predictive parser. Then first and follow, parsing table, stack implementation, and then we will discuss how to make the parse tree. So parsing can be done in two types, top-down parsing and bottom-up parsing. So when the parser starts constructing the parse tree from the start symbol and then tries to transform the start symbol to the input, then this type of parsing is called as a top-down parsing. And in bottom-up parsing, parser starts with the input symbol and tries to construct the parse tree up to the start symbol. So that's it, bottom-up parsing. So here we start with the starting symbol, here we start with the input symbol. So there is a non-terminal in the starting, here is the terminal in the starting. So in this lecture we will discuss basically the top-down parser, and top-down parser basically categorized or can be called as a recursive descent parser. So recursive descent parser further divided into two types of parser with backtracking and parser with non-backtracking. So non-backtracking parser is also called as a predictive parser that we will discuss in this lecture, and that also called as a LL parser. So here first L is left to right, and next L is leftmost. So left to right, leftmost derivation is the full form of this LL parser. So in this lecture we will cover this topic, not backtracking and other parser. So predictive parser is a recursive descent parser which has the capability of predict which prediction is to be used in the place of the input string, and the predictive parser doesn't suffer with the backtracking. So there is no problem of backtracking in this predictive parser, as its name says that this is a predictive parser. So parser knows in advance which prediction rule he need to opt to do parsing, right? So that's why its name is parser, predictive parser. So predictive parser uses a stack and a parsing table to parse the input and generate the parse tree. So there is a need of stack. So it will use a stack, and stack and input, both stack and input contain an AND symbol dollar to denote the stack whether it is empty or not. So we will use dollar symbol at the end of the string to check whether a stack is empty or not. And this parser also refers the parsing table to take any decision of the input and stack element combination. So there is an stack, there is an input, there is a parsing table, and there will be some output generated by this parser, that will be the parse tree. Now, as we told you that predictive parser is also called as a LL parser. LL matlab left to right, leftmost derivation, and LL parser is also called as a LLK parser. If it uses the K tokens of look ahead when parsing a string or a sentence. So K is a number of tokens of look ahead. So if there is one one token of look ahead as an input, to this parser will be called as a LL1 parser, right? So LL grammar, particularly LL1 grammar parser, are easy to construct, and many computer language are designed to be LL1 kind of parser. And this one, as I told you, that this one is a one input symbol of look ahead at each step to make the parsing action decision. So to construct the LL parser, there are following requirements. Then the grammar should not have left factoring grammar, and they should not be left recursion. So no left factoring, no left recursion should be present in the given grammar. Then we need to construct the first and follow. Then we need to construct the parsing table. Then we will do stack implementation. At the end, we will construct the parse tree. So initially, the grammar should not have left factoring and left recursion in the rules, and then we will calculate first and follow. Then we will calculate parsing table, then stack implementation, then at the end we will make the parse tree. So step first is first and follow. So there are some certain rules of calculating the first and follow. So rule number 1 says that for a prediction rule, x tends to epsilon. If there is a prediction rule of x to epsilon, then the first of this x1, first of this x will be epsilon itself. So this is rule number 1. Rule number 2 says that for any terminal symbol A, the first of A will be itself that terminal. So this is rule number 2. And for rule number 3 says that for any prediction rule x, if there is a prediction rule x to y1, y2, y3, then how will we calculate this first of this prediction rule? So to calculate the first of this x here, there are some certain conditions. Then if epsilon is not the part of this first of y1, then the first of x will be the first of this y1. And if epsilon is the first of y1, then first of x will be first of y1 minus that epsilon value, and then we will union the next y2 and y2, y3 first. And with the same rule, we will calculate the first of y2 and y3. If epsilon is not the part of y2, then first of y2 and y3 will be the first of y2. And if epsilon is the part of y2, then we will check the y3 as well. So with the example, we will see how we are calculating the first of any prediction rule. Now, rules of follow. So there are certain rules of calculating the follow as well. So rule number 1 says that the first symbol S, the follow of S will be $. So if there is S is the first letter or a first symbol of a prediction rule, then the follow of this S will be $. Rule number 2 says that for any prediction rule, A to small a, capital B, if there is a prediction rule A to small a, capital B, then the follow of this B will be follow of this A. If there is no value at the end of this B, then the follow of this B will be equal to follow of this A. follow of this B will be equal to follow of this A. If there is no value at the end of, or you can say that if no one is following this B, then the follow of B will be equal to follow of A. Now, follow of rule number 3 says that for any prediction A, B, beta. A is a terminal, beta is a terminal. Then the follow of this B, will be, who is following this B? This beta. So the following of this B is first of this beta. If this is not a terminal, then the first of this beta, as well as the union of follow of A, if epsilon belongs to this first. If epsilon doesn't belongs to this first, then the simple first of this beta will be the follow of this B. And we need to remember when we are calculating the first and follow. So especially for follow, the note number 1 is that if epsilon may appear in the first prediction of a non-terminal, then epsilon never appear in the follow function of any non-terminal. So there will be no epsilon in the follow when we are calculating the follow of any prediction rule. And before calculating the first and follow function, elimination of left recursion from the grammar if it is present. So firstly we need to remove the left recursion if it is present in the grammar. So we will eliminate it, then we will calculate the first and follow. We calculate the follow function in the non-terminal by looking whether it is present on the right hand side of the prediction rule. So to calculate the follow, we will always see the right hand side of the prediction rule, not the left hand side. And when we are calculating the first, then we will look at the left hand side, not right hand side. So there is some important note we need to always remember when we are calculating the first and follow. So let's see with an example how we are calculating first and follow of any prediction rule. So suppose there is a grammar, given grammar E to T E dash, E dash 2 plus T E dash oblique epsilon, T to F T dash 2 star F T dash oblique epsilon, and F to E oblique I. So this is the given grammar and we need to calculate first and follow of this prediction rule. So left hand side we will write all the symbols that are generating the prediction rule: E, E dash, T, T dash, F. Now first of this E, what will be the value of this first of this E? So any terminal that is generating by this E, and we will see any terminal that is generated by this E. No, there is no terminal generated by this E. So what we will write? We will write like this. There is a T in this right hand side. So T is generating Ft dash. F is again the non-terminal. Then what F is generating? F is generating this bracket. So the bracket, open bracket, will be the first of this E. Right? So you can see the open bracket will be the first of this E. Now If I will not replace with this open bracket, there is another production rule, ID. So I can replace this with the ID as well. So now the first of this E will be ID as well. Hope it is clear how we are calculating the first. So first we write the rule, then we will replace it, and we will check the first terminal symbol generated in the right hand side is called as a first of this production rule. Now we will calculate the follow. The follow rule says that dollar will be the first follow when this E is when a symbol is a starting symbol. So E, as we know that the starting symbol of this grammar, so the dollar will be the first of this E. Now to check the follow, we also need to see the right hand side of the production rule. So in the right hand side of the production rule, we will see where is E. E is here. Now who is following this E? Close bracket. Close bracket is following this E. So close bracket will also the part of this follow. So you can see open bracket and ID will be the part of this first dollar, and close bracket will be the part of follow. Now let's see another symbol, E dash. E dash first is plus, as it is generating directly the terminal symbol in the right hand side or starting symbol, and it is generating the epsilon in the first. So epsilon will be the first of this E dash. Now E dash, to check the follow of this E dash is present here. So E dash, nobody is following this E dash. So as per the rule number 2, all the follow of this E will also the part of this follow of E dash. So all the part follow of this E will also the part of this E dash. And similarly, E dash is present here. So again, there is nobody is following this E dash. So all the follow of this E dash, again the same thing, dollar or close bracket will be the part of this E dash. Now T. To calculate the follow of first of T, so we will write the rule ft dash. Now F is not the terminal, so we will replace it F2 open bracket E. So now we can see the first of this T is F starting bracket. If I am not replacing this rule, I can replace, I have two options, whether I can use this rule or whether I can use this ID. So now this ID will be the part of this first. Similarly, to check the follow, we will see whether T is present in the right hand side or not. Yes, T is present in the right hand side of the production rule of first. So who is following T? Following of as per the rule number 1, who is following T? E dash is following T. Now how we can replace? This is not the terminal. We can replace this plus. Now who is following this T? Plus is following this T. So plus will be the follow of this T. Now can I replace this rule with another rule? Yes, we can. I can replace this E dash to T E dash. Yes, I can replace what? This T with plus T. Now I can replace with T this T with epsilon as well. Now at this condition, who is following? Sorry, not here.
I can replace this E dash to epsilon. Who is following T? Nobody is following this T. So all the prediction rule of all the follow of this E will be the part of this T. So all the follow of this one will also the part of this. Again, we will see the rule. There is a rule E to T E dash. First we replace this T with plus so replace E dash with this plus. So the follow of T is this plus. I just write here. Now if I am not using this rule, plus rule, then I can replace what? Epsilon. So all the follow of this V will be the follow of this T. Similarly, we calculate first of T dash here, follow of T dash here, follow of first of this F, first follow of this F with the same prediction rule. Now, second step is to calculate the parsing table. So, with the same example, we will see it how to calculate the parsing table. So, to calculate the parsing table, we required first and follow. So, first symbol and follow symbol table, same table we will write here to calculate the parsing table, and we will see this table to make this parsing table. So to fill this value of this input symbol, we will write the terminal value here and we will write the non-terminal value this side. So ID is the terminal, plus is the terminal, star is the terminal, open bracket, close bracket, and dollar is the terminal symbol. We will write upper side, and all the non-terminal we will write left hand side. So to fill the value of this table, this parsing table, what we need to check the first and follow. So when we will see the first and when we will see the follow, there is a rule. If there is an epsilon present in the first, then we will see the follow. Otherwise, we will just see the first, right? If there is a epsilon in the first, then we will see the follow as well. Otherwise, we will see the first only. So, E to T E dash, E to T E dash. So, we will see the first, this open bracket. So, open bracket and ID. Both places we will write the rule T E dash. There is no epsilon in this first. We will not see this follow. Now next, E dash 2 plus T E dash. Where we will put it? We will see the first. Now plus. At the location of plus, we will write the rule E dash 2 plus T E dash. Just right. Now there is a epsilon in this first, then we will see the follow as well. So the rule that consists of E dash to epsilon will be put it as per the entry of this follow. So at the place of dollar and close bracket, we will write the rule E dash to epsilon. Close bracket and dollar, we will write the rule E dash to epsilon. Similarly, for T to FT dash, we will write at the place of starting bracket and ID. So starting bracket and ID, we just write the rule. There is no epsilon, so we doesn't need to see this follow entry. Again, T dash to star F T dash will be put it at the place of star. We just write here. Now there is an epsilon. So rule generated with epsilon will be put it at the place of these entry of follows. So close bracket dollar and plus, close bracket dollar and plus. We just write the T dash to epsilon, T dash to epsilon, T dash to epsilon. Now F E I D, this rule will be put it as per the entry of this open bracket and ID. There is no epsilon, so we do not need to see this follow. So the rule consisting with open bracket will be put it at the entry of this open bracket, and rule consist of this ID will be put at entry of the ID. So just F2 ID we will write at the ID place, and the rule consisting of this open bracket will be right here. So in this way we can make this parsing table. So if there is no multiple entry in this parsing table, then we can say that this grammar is perfectly LL1 type of grammar. And if there are multiple entry in any cell of this parsing table, then we will say that this grammar is not LL1 grammar. So the third step is stack implementation. The predictive parser make use of explicit stack to keep track of all the pending non-terminal, and it can thus be implemented without the recursion. As I told you, there is no backtracking. And there is one note we need to remember, that the production output are tracing out on the leftmost derivation only. And the grammar symbol on the stack make up the left sentential form only. As its name says that it is left to right, leftmost derivation. So we will see the stack implementation for the same grammar, for which we calculate first and follow. And there is an input string given in this question, ID plus ID into ID, that we need to parse. So first we will see the predictive parsing table, through which we will make use of the stack implementation. So let's see. First we will write the stack, then we will write the input, then we will write the action here. So starting symbol here is E. At the end of this stack we will write the dollar symbol, and then we will write the input string here. Then we will see the predictive table just to parse this string. So E to ID. So E to ID, there is a rule written E to TE dash. E to TE dash is a rule corresponding to this E to this ID. So we will write in reverse order. TE dash dollar. Now this T to this ID. Again we will refer this table. T to this ID. There is a rule T to FT dash. T to FT dash we will write here FT dash T, same. Action is this one. Now F to this ID. F to this ID. We will see again F to this ID. There is a rule FID. FID is a rule. Then ID and ID. Now if this value and this value get matched, then we will pop out. Now similarly, remaining part is T dash E dash. Again T dash 2 plus. We will refer the parsing table. Then again there is a match. T dash to epsilon. So we will replace this with the epsilon. So remaining part is e dash. E dash to plus, there is a rule. E dash to plus t e dash. So we will write e dash to plus t e dash here. Now plus plus get match. This value will be pop out. Remaining value will be here. Again we will see t to id. There is a rule t to ft dash. We will write here ft dash. Then again f2 id. There is a rule f2 id. We will write id here. id and this id get match. This id get match. Then this will be pop out from the stack. Now this t dash to star we will match. We will see here t dash. There is a rule. We will write here plus ft dash e dash same. Now this star get match. This will be pop out. Same f2 id, there is a rule. Yes, f2 id, there is a rule. We will replace this id get match. This will be pop out. Now this t dash e dash, t dash to dollar, there is a rule. T dash to dollar, there is a rule called as a t dash to epsilon. We will replace this epsilon here. Then remaining is e dash to dollar, there is a rule. E dash to epsilon we will replace here. Now dollar. Now stack is empty. So all the string have been parsed. So now the next step is to make the parse tree. So in this order, when we match the string, we will construct the parse tree. So top-down parsing expands the parse tree from the starting symbol and leaves to the leaves, and always expand the tree leftmost non-terminal. So in this way, we can make the parse tree for the given string id plus id into id. So first we replace with this id. So first we will replace this id after replacing these three terminals. So in this way we can make all the terminals will be at the leaf side only. So this is the way of constructing the parse tree in a top-down manner using the parser LL1. Thank you.